Hi everyone, in this video I will be discussing integration by parts using DI or the tabular method. So in my previous video discussion, I have discussed integration by parts using the long method. And just to recall, our formula for that is the integral of u dv is equal to uv minus the integral of v du. But just a reminder, although we will be having a shortcut for the integration by parts technique, this shortcut doesn't work for all cases, so it doesn't apply to all the cases. It depends upon the types of function that we are integrating. So let's have an example. Number 1, we have the integral of x sine x dx. Now before we integrate using the tabular method, let's recall first the technique or the method in order to determine as to what our u or dv will be when we had integration by parts using the formula. So L stands for logarithmic, I for inverse trigonometric, A for algebraic, T for trigonometric, and E for exponential functions. So still we'll be applying LIATE, L-I-A-T-E, but this time in order to determine what will be the function that will be differentiating, which is under the D column, and the function that we will be integrating under the I column. So here we are given x and sine x. So x, that's algebraic, sine x, that is trigonometric. So in LIATE, algebraic comes first before trigonometric. So under the D column, we will have x. Under the I column, we will have sine x. So D and I will be the indication whether you will look for the derivative or if we will integrate that certain function. So since x is under the D column, so we will look for the derivative of x until such time that we will arrive at 0. So looking for the derivative or solving for the derivative, that is simply 1. And for the second time, looking for the derivative of 1, we will have 0. Now since for the D column there are 3 rows, we'll do the same for the I column. So we will integrate this function 2 times. So the integral of sine x, we have a formula for that, is cosine x. After that, integrate once more, solve for the integral. So just copy the negative sign and we will just look for the integral of this function, cosine x. And as a recall, just to review, the integral of cosine x is simply sine x. After that, we will assign symbols, positive and negative sign, and it should be alternating. So that's positive, negative, positive. If ever we will be having additional rows, so we will keep on alternating the signs. After that, draw diagonal lines, x to cosine, negative cosine x, and 1 to negative sine x. So let's go ahead and answer or look for the integral. So integral of x sine x dx is equal to, so multiply x times negative cosine x, that's negative cosine x minus, or no, negative 1 times negative sine x, that is plus sine x. Then do not forget the constant of integration, c. Therefore, this is the integral of x sine x dx using the DI or the tabular method. For our second example, we have the integral of x cubed times e raised to x dx. So, using the acronym LIATE. So, this is an algebraic function. This is an exponential function. So, algebraic comes first before exponential. So, under the D column, we will place x cubed. Under the I column, we will place e raised to x. So, solving for the derivative of x cubed, that is 3x squared. Since for derivative, put the exponent or bring down the exponent here, then subtract 1. So further solving, looking for the derivative, we will have 6x. Then the derivative of 6x is 6. And the derivative of 6 is 0. Now for e raised to x, since this is an exponential function, if you can still remember or recall that the integral of e raised to x dx is simply e raised to x plus c. So even if we integrate this one for n number of times, it will still be e raised to x. Now, placing the sign, positive, negative, positive, negative, positive. It's always alternating. Then, multiplying diagonally. And finally, solving for the integral. That is equal to x cubed e raised to x minus 3x squared e raised to x, e raised to x plus 6x e raised to x minus 6 e raised to x. We stop there since the next number is 0. Then again, do not forget your constant of integration, c. So this is the integral of x cubed e raised to x. That's very easy, right? Compared to if we will be solving using the long method. But then again, as I've mentioned earlier, it's not all the time that we will be able to apply the DI or the tabular method, since there are certain limitations. So here, one of the requirement is for us to arrive at 0. So this will only apply for algebraic. So what about for other types of functions like logarithmic, inverse trigonometric, or exponential? So let's have an example for that. For our third example, we have the integral of x raised to 5 ln x dx. So this function, that's algebraic. This is natural logarithmic. So going back to LIATE, LIATE, so logarithmic comes first before algebraic. So under the D column, we'll be placing ln x. Under the I column, we'll be placing x raised to 5. Now, solving for the derivative of ln x, if you can still remember, that is 1 over x dx. And for deriving this one, since this is a quotient, so we'll be applying the quotient rule. And at the end, we will not be able to arrive at 0. So we stop there. And for the integral of this one, using the power rule, that's x to the 6th power over 6. So actually, we can't apply the tabular method here. But if you can observe, if you can still remember when we solve for the integral integration by parts, so that's u dv, integral of u dv equals uv minus integral of v du. This part right here, this is our u, this is our du, this is our dv, and this is our v. So therefore, we go back to our formula. So this is one of those cases again where we still go back in using the long method. So going back to our long method, substituting, that is the integral of u dv, which is x to the 5th power ln x dx, that is equal to uv, which is ln x times x raised to 6 over 6 minus the integral of v du. So our v is this one, that is x raised to 6 over 6 times du, which is 1 over x dx, since we are now solving for the integral. Now simplifying, that is x to the 6th power over 6 ln x minus, we can actually simplify this one. This one will be left with x. So we can also put 1 over 6 outside of the radical symbol. So that's 1 over 6. I'm sorry, not radical, integral symbol, 1 over 6. Then what will be left is x. No, this should be 5. I'm sorry, that should be 5. Since there's only one x, so quotient rule, x to the power of 6 over x is x to the power of 5 dx. So further simplifying, that is x raised to 6 over 6 ln x minus, that is 1 over 6 using the power rule times x the power of 6 over 6, since you add 1 there. So for the final answer, that is x let me just move the solution here. So that is x to the power of 6 over 6 ln x minus 1 over 6 times 6, that is x to the power of 6 over 36 plus the constant of integration c. So still we went back to using the original method, since the di for the tabular method cannot be applied. But then again, whenever we have the algebraic function to be our d, then in most cases we will be able to apply the di or the tabular